Hello there, thank you for watching this video. Today I will be covering chapter 3 of CCNA exam, point-to-point connection. It's separated in two parts, so this is part 1 by me, Astrid Krasniqi. Now today we will be covering serial communication. In there we'll see the difference between serial and parallel port, serial communication standards. Then we will continue talking about time division multiplexing, statistical time division multiplexing, then demarcation point, data circuit terminating equipment, DCE. Then we'll talk about data terminal equipment, DTE. Then we talk about serial bandwidth, WAN Encapsulation Protocol, and troubleshooting a serial interface. And last, I will do a demonstration onto troubleshooting a serial interface. Okay, let's get started. Serial and parallel ports. Now, a big difference here. Let's think about it. Serial port will send 1 bit at a time. Parallel port will send 8 bits at a time. Now, if you send 1 bit at a time, compared to 8 bits at a time, 8 bits sounds better. So which one would you go for? 8 bits or 1 bit? Now, surprisingly, 8 bits is worse. If you watch the video, like a small video here, if the bits, they will continue traveling through the serial port. But as you can see, not all the bits are arriving at the same time. So there's a difference. Now, some of the bits, like this bit here, it has, for example, has stayed behind. And the other side is not going to start sending any more bits until everything reaches. So there's 2 factors that affects the parallel communication. One of them is called clock skew, and the other one is crosstalk interference. Clock skew, what it means is this: the bits, they're not going to arrive same time as when you send them. So some bits that will arrive first, some other bits will arrive later, and then that will cause a problem. Crosstalk interference is that every bit it will have a potential to be interfered with any other bit or any other surrounding around the cable. So for that reason, serial communication is worse. Parallel communication is worse than a serial communication. Serial, you'll send 1 bit at a time. We have some serial communication standard. First of all is RS-232. Now you've seen these are like the console cables that we connect them to the one side to the back of the PC and the other side in the router. So both we have 9-pin and 25-pin connectors are used. Many network devices use RJ45 connectors that also conform to the RS-232 standard. Then we have V35. Typically used for modem to multiplexer communication. This ITU standard for high speed synchronous data exchange combines the bandwidth of several telephone circuits. Then we have a HSSI, a high speed serial interface, supports transmission rates up to 52 megabits per second. Now, time division multiplexing shares available transmission time on a medium by assigning time slots to the users. The MUX accepts input from an attached device in a round-robin fashion and transmits the data in a never-ending pattern. It will just continue in round-robin fashion to transmit data. The T1 and E1 and ISDN telephone lines are common examples of synchronous TDM. So here we have the MUX, and we have for example, voice, data, and the video traffic that needs to go from this side to the other side. The MUX will have like an 8-bit time slot per data, per video, and per voice. So as they start traveling, this stuff, the MUX will just keep them in the 8 time slots. Now, statistical time division multiplexing, SCDM uses a variable time slot length, allowing channels to compete for any free slot space. So instead of a TDM, we'll just reserve data for voice, reserve a slot for video. SCDM doesn't. SCDM, we will just let the data actually compete, and voice and video to compete for the free slot. so it won't waste any free slot. STDM does not waste high-speed line and time with inactive channels using this scheme. Demarcation point. Now demarcation point is point marks the point where your network interfaces with a network owned by another organization. So here, for example, United States, demarcation point, this is demarcation point. So everything on this side is the ISP's responsibility. So any device or anything that goes wrong on this side is the ISP who's going to be responsible for. Anything from the demarcation point and this side, it's your responsibility or the customer premises responsibility. So for example, CSU, DSU, you can see it's the customer's responsibility. While in Europe or international, we have the demarcation point is behind the DCE. So demarcation point is at this point. Whatever it goes wrong on this side, then you have the ISPs is their responsibility to fix the problem. Anything that goes wrong on this side, then it's your responsibility or the customer responsibility. For example, we think about the demarcation point at home. Do you know where is your demarcation point between you and your ISP provider? Let's think about it. Usually it's at the next to the front door. The panel where you put the phone, the plug, that's the demarcation point. Anything from that plug and on is the ISP's responsibility. If it's inside your home, then it's your responsibility. Point to the network where responsibility of the SP ends. So point in the network where the responsibility of the service provider ends. Data circuit terminating equipment, DCE, and data terminal equipment, DTE. Remember, DCE provides a clock-in. DTE takes the clock-in, synchronize. So DTE device is a terminal or computer, generally a router. A DCE, commonly a modem or CSU DSU. The signal is received at the remote DCE, which decodes the signals back into sequence of bits. The remote DCE then signals this sequence to the remote DTE. For example, if you're connecting from this PC with a modem, then your PC is the DTE and the modem is the DCE. If the router is connecting with a CSU DSU unit, then the router is DTE and CSU DSU unit is DCE. Serial bandwidth. So here we have a link type and bit rate capacity. So first of all, if we have 56 kilobits per second, 64 kilobits per second, these are the modem speeds. Then we have T1, 1.544 megabits per second, E1, 2.048 MB, E3, 34 megabits per second, T3, 44.736 megabits per second. Then we have OC1, OC3, OC9, OC12. OC stands for optical carrier. Now OC is 51.84 megabits per second. Now when I was starting to learn this Cisco or CCNA, I was told that if you think of OC, it's like a year, and a year is 52 weeks. So that equals similar to 51.84 megabits per second. So if you get a question, for example, what's OC3? All you have to think of it, okay, OC3 is like a 3 years, and a year has 52 weeks. Then I just have to time that 52 by 3. There you go, that's the answer. So 156, which is closest to 155, so you will get the correct answer. Okay, so we can think of it, OC is like a year, and it has 52 weeks in a year. That's next to 52 Mbps, sorry, megabits per second. WAN Encapsulation Protocols. We have the leased line, which the protocols that we have on the leased line are HDLC, the default encapsulation type on point-to-point connection, dedicated link, and circuit switched connection when the link uses 2 Cisco devices. Then we have PPP, provides router-to-router and host-to-network connection over synchronous and asynchronous circuits, and serial line internet protocol, SLIP, a standard protocol for point-to-point serial connection using TCP/IP. SLIP has been largely displaced by PPP. We don't see anymore. The PPP is used. Then we have a circuit switched network. On the circuit switch network, we have a Cisco HDLC, also known as CHDLC, is an extension to the high-level data link control network protocol created by Cisco system. Cisco has developed an extension to the HDLC protocol to solve the inability to provide multi-protocol support. Then we have a packet switch. On the packet switch network, we have X.25, Link Access Procedure Balance, LAPB, then frame relay, handles multiple virtual circuits, eliminate times consuming process such as error correction and flow control. Now X25 had lots of headers for error correction and flow control and so on, because they was using really old or legacy lines. Now frame relay has replaced that because it was newer, there was less errors, so it doesn't use these anymore. Then we have ATM, which uses fixed 53 bytes cells. To troubleshoot the serial interface, we will do show interface serial 000 and see if the interface is up, if protocol is up, what kind of encapsulation we are seeing, bandwidth, what bandwidth we have. Well, that's not going to solve that many problems, but encapsulation usually is the problem. Then we can do show controller serial to see if the clock is being set and to see what side of the serial link you are. Are you DCE or DTE? Now status line, possible condition, problems and solution. Status line, when we do show IP interface brief, we can see maybe up. If we see serial is up and line protocol is up, then the protocol status is good, it's working, no action is required. If we see down, there's no sensing of any signal, so we verify that proper cable and interface are being used. If we see up-down, maybe the clock rate interface configuration command is missing, a timing problem has occurred. So use the show interface serial command to determine whether the line protocol comes up. Administratively down, the router configuration includes the shutdown interface. So the administrator just didn't do no shutdown. Now we don't have it on the screen here, but I usually tell the students, for example, sometimes I've seen a question, what happens if the serial says down here and line protocol says up? Well, that's never going to be the case, because in serial X here, it shows layer 1 information. In line protocol is layer 2 information. So if layer 1 is down, layer 2 will never be up. So that will be never the case where you see the layer 1 down, layer 2 up. Always, if layer 1 is down, then layer 2 is going to be down as well. If layer 1 is up, then layer 2 can be down or up. Okay, now I will show you the demonstration on troubleshooting a serial interface. For this, I'm going to use a packet tracer. This is packet tracer activity 2.1.7, troubleshooting a serial interface. Okay, now for this exercise, what do we need to do is PC1 wants to ping PC3, but there's a problem. So we're gonna find out where is the problem, what's happening. So simulation here, simulation mode is locked, we can't use that, so we just have to go there with the PC and find out. So the PC address, IP address is 192.168.10.10, and the gateway of that PC is this router here. So I'm just going to write here 192.168.10.1. Okay. And the PC in question here that we're trying to ping is 192.168.30.10. Okay, let me just check that, make sure. So I'll open the PC3. I just clicked in the middle of the PC3. Go to the command prompt and type ipconfig. Yep, 192.168.30.10. That's the address of this PC. Now from PC1 we try and ping PC3. So we go open the PC1, go to desktop, command prompt, and then ping 192.168.30.10. So that's the IP address of the PC3. We get a new reply, but the reply is from our gateway. So it says reply from 192.168.10.1, destination host is unreachable, so it's not working. To find out from this PC what is the problem, or where the packets are dropping, we can use a tracert. Tracert 192.168.30.10. So we can see the packets are going to our gateway, and that's it. They're not going any further. That's it. We don't see it any further than the gateway. So they're reaching the gateway. Okay, Control C to break that sequence. Now what we need to do is go to the gateway, telnet to the gateway. So we telnet in from PC1 all the way to the gateway, to that port here. So PC1 telnet 192.168.10.1. Okay, the password is Cisco, enable, and then enable password is class. Okay, now we are inside the router 1 interface. In the router 1 we're gonna see where the problem is. There's some commands that we can see to start troubleshooting. Is show IP interface brief. Now for this we can see the fast Ethernet. The interface is connecting to the PC, to us now, to PC1. It's up, status is up, and protocol is up. So it means everything is working fine. There's no problem. In 0000, the status is up, so there's power there. There's electricity or current, but the protocol is down. Okay, so we'll see what that problem is. So show controllers interface, not interface, just S000. Now S000 says, yep, this is DC, and there's a clock right here. So that's fine. That's not a problem there. Show interface serial 000. See that interface. Here it says serial is up, but line protocol is down or disabled. Now that will tell us that it could be a problem with the encapsulation or with the protocol that we are using. Now we are using the default protocol, well, not the default. In this side we are using PPP, encapsulation PPP. On the other side they may be using a default protocol. Since we don't have any access how to get to that side, we can't even telnet. Maybe we can just change the protocol. That could be the problem. It could be the problem. Okay, so if I go to PC1 again and just run show CDP neighbors. So as a neighbor I can see my switch only. That's a switch here that I can see, but I can't see router 2 as a neighbor. So there's a problem in this link. So show interface IP interface brief. We can see the serial 000, layer 1 is up, layer 2 is down. So we're just gonna change the encapsulation type. Maybe that was the problem. So config T interface serial 000 and encapsulation HDLC. Okay, and then we do show CDP neighbor. Whoa, that's it. We got router 2 as our neighbor. So the interface should be working now. Show interface IP interface brief. Yep, the serial 00 says up, serial line, its status is up, and protocol is up. So show CDP neighbor detail. Now the IP address of router 2 is 10.1.1.2. Okay, so let's try and ping that. So ping 10.1.1.2. Yep, we have a reply. So the connection from this PC to the router 2 should be fine, no problem. Okay, so I'm gonna exit from here and see if that fixed the problem. So I'm gonna try and ping again from PC1, try and ping PC3. If I go to PC1 again and say ping 192.168.30.10. No, still is not working. Okay, so Control C to break that, and then tracer. Oh, now it's not that it's just not pinging, but there's a loop. There's a loop here. What happened? The packets are going to the gateway, and from the gateway, from router 1, it's going to router 2. Then router 2, it hasn't got a destination, so it's got like a IP route, all zeros, towards the ISP, and it just sends it to ISP. But the ISP saying, well, this packet belongs to your network, so it's just sending it back. And the router 2 is sending to ISP, and then backwards and forwards. So there's a loop there. So if I say to again to PC1, repeat the command, so you can see the packet is going from our gateway to router 2, and from router 2 and ISP is just looping. There's a problem there. Okay, so if I telnet again to router 1, 192.168.10.1, Cisco enable class. Now I'm in router 1. Router 1. So from router 1, show IP interface brief. Yep, router 1 is all fixed. So we need to telnet to router 2. So telnet 10.1.1.2. Cisco enable. Okay, now we are in the router 2. So show IP interface brief. Okay, the interface is connecting to router 1. It's up, status is up, and protocol is up. The interface is connecting to the ISP. It's up, the status and protocol is up. But the interface that connects to router 3, the status is down and the protocol is down. So there's a problem there. Let's see, maybe show run to see our configuration for our interface. So we are looking at this interface. Interface serial 0/0/1. Description link to R3. This the one is down. Okay, there's no clock there, but maybe we are not the DCE. So let's just go and check that. So show controller serial 0/0/1. That's the interface that connects to R3. We are the DCE, and there's no clock. So we have to go and set that. Config T, interface serial 0/0/1, clock rate 64,000. And show IP interface brief. That still didn't fix the problem. Still status down, protocol down. Show run. Okay, so now we have the clock. Serial 0/0/1. It has a clock. Still didn't fix the problem. Show interface serial 0/0/1. Now here it says serial 001 is down and the protocol is disabled. Encapsulation is HDLC. Okay, show CDP neighbor. It's got the ISP as a neighbor and router 1 as a neighbor. So router 3 is not our neighbor. Okay, there's a problem here on this link. It's a red color anyway. It means there's a problem. So the only way for us to get to this router to see where the problem is, we have to go telnet from PC3 to R3. So we go to PC3, command prompt. So first we ping our gateway 192.168.30.1. Yep, we have a reply. Telnet 192.168.30.1. Cisco enable class. Okay, show IP interface brief. This is a problematic interface. 10.2.2.2, and it says administratively down. So if you remember from the previous lessons, administratively down just means the administrator didn't do no shutdown. So let's go and do that. So config t interface serial 001 no shutdown. And show IP interface brief. Show IP interface brief. Okay, now it's gone up, so it's working. Let's go to PC1 again. Now we are in router 3, so if you repeat the command show CDP neighbor, now we have a router 3 as a neighbor as well. Well, that's great. Show IP interface brief. Yep, everything is working. Exit from here, exit from here. Now we're back in PC1. So if we repeat the command, tracert 192.168.30.10. Whoa, everything is working great. So the first packet went to our gateway 192.168.10.1. From the gateway, send it to the router 2 10.1.1.2. Then from the router 2 went to the router 3 10.2.2, and then to the destination 192.168.30.1. So everything worked fine there. If we ping 192.168.30.10, no ping. Yep, we got a reply. So on troubleshooting, what we did now is we saw there was a problem with router 1. The encapsulation was different to router 2, so we changed the encapsulation to default. So the encapsulation was PPP. That was a problem. So they wouldn't communicate. So obviously these two, they have to have a same encapsulation on the link. So we changed the encapsulation to HDLC. Then the router 1 did communicate with router 2. And we went from router 1, we telnetted to router 2, and then from router 2 we looked at the interface and we saw that there was no clock. So we just made sure that we are on that interface, we meant to have the clock. So we did show controller serial 001. We saw that there is meant to be a clock in, but it wasn't set. So we went to that interface, we set the clock, we fixed that problem. It still didn't fix the link. So then we went to PC3, we telnetted to R3, we checked, and the administrator forgot to do the no shutdown. After we did no shutdown, the whole network is working fine now. Okay, so that was the troubleshooting. This was the task on Packet Tracer. What number was this? 2.1.7, troubleshooting a serial interface. When we come back, we'll do the second part of this lesson. So chapter 3, point-to-point connection. This was part 1. We come back, we do part 2. On this lesson we talked about serial and parallel port, the difference between both, why serial port is much better than parallel port, serial communication standards, Then we looked at time division multiplexing, then statistical time division multiplexing, demarcation point, where the demarcation point lays, data circuit terminating equipment, DCE, and data terminal equipment, DTE. These are the computer or the router, and DCE is the modem or CSU, DSU. Then we had a different serial bandwidth type, WAN Encapsulation Protocols, troubleshooting a serial interface, and then you saw the demonstration how to troubleshoot a serial interface. Thank you very much for watching. We'll see you in the next video.